Hello, and welcome back to Problems from the Final Exam Review for Statistics. We're starting with problem number 14 today. It says a shoe manufacturer claims that athletes can increase their vertical jump heights using the manufacturer's new strength shoes. The vertical jump heights of 8 randomly selected athletes are measured. After the athletes have used the strength shoes for 8 months, their vertical jump heights are measured again. Find the difference, the after minus the before. So we have after minus before. And so because we're creating a difference specifically with each individual athlete, this is considered dependent. Each athlete is paired before and after with themselves. So these are dependent, two samples that are dependent. This would be less than 10.4 then, because it's dependent samples. Okay, so they said to do after minus before. So this would be 2, 3, 0, 1, -2, 2, 5, and 3. So at the alpha point 10, is there enough evidence to support the manufacturer's claim? Assume vertical jump heights are normally distributed and use the classical method showing all work. Okay, so they want to see if they've increased their vertical jump. So we have HOHA. We're going to go to our formula packet for 10.4. Remember, that's page 305. Two means that are matched pairs. And so this is exactly how you're going to write your hypothesis. You're not going to write subtraction of before and after. You're going to write the difference. So we're writing the mean difference is equal to 0. And they want to see if the mean difference is greater than 0. Because it said that there's going to increase their vertical jump. So if we after minus before, it should be positive. It should be greater. Okay. So then alpha is equal to 0.10. 3 is going to be a critical T, because we're basically just doing a one sample now, because our sample is just these difference values. So it's going to be a T0, T distribution. Make sure you pay attention to that. We can just go to our program in Desmos for a one sample mean. So it's 10.4. You're using a one sample mean in Desmos though. And then we're going to be looking for our p-value, and we're going to compare that to alpha, which is 0.10. And it's a right tail test because it's a greater than. So let's go ahead and go to Desmos for that. And so in Desmos, the first thing we have to do is we have to find the mean of our data, our difference data. And I already took the differences, so I'm just going to type those in. 2, 3, 0, 1, -2, 2, 5, and 3. And so I have to find the mean of that difference data and the standard deviation of that difference data. So the mean of the differences is equal to 1.75, and the standard deviation of the differences is equal to 2.12. I'm just going to go back and show you my paper. So I just jotted those down. The mean of the differences and the standard deviation. So let's go back to our program. So our program in Desmos is up here. And we have 8 in our sample. And our sample mean is 1.75. Our sample standard deviation is 2.12. We're testing the H0 at equal to 0. So our test statistic is 2.33. our T0 is 2.33. And we don't have to worry about putting alpha in because it's only for a confidence interval. And we're going to go down and we're clicking on the greater than, the right tail test. And if you click over here in the circle, it actually just puts everything right on your screen in the graph. So our probability is, our p-value is 0.0261. And so I'm going back to my paper here and I can tidy everything up. And my p-value is definitely less than alpha, so we do reject H0. So there is sufficient evidence to support the claim that the shoe increases the athlete's vertical jump height. So we do reject H0, so there is sufficient evidence. And I missed the word evidence. Number 14, the final review. Okay, I'm going to skip to 17 because it's a similar problem in that assume that the paired differences come from a population that is normally distributed. So we don't have any context to this, but they're paired differences. And so again, it's going to be 10.4 that we're using. And they want us to take the X minus the Y. So I'm doing the top minus the bottom. So 0.7. Now, these numbers are a little bit trickier to find. So what I think would be good to practice is let's just go to Desmos and start a new table. And I'm just going to put my X's in just like they have them. And you should practice this as well, because you may have to do this on the exam. And then my Y's. Okay. And then I'm actually going to find the mean, but I'm finding the mean of X1 minus Y1. And then I can also find the standard deviation of X1 minus Y1. And so the mean of the differences is negative 0.1667, and the standard deviation is 0.4502. And if you want the actual differences, notice I'm creating a third column here, and I can just say X1 minus Y1. And so then you can fill those in on your in your table, because you may need to do that on the final exam as well. Okay, so I'm going to go back to my paper for just a moment so you can see where we're at. Now it says to test the hypothesis that the mean difference is less than 0. So we've got H0, HA. So the mean differences are equal to 0 and the mean differences are less than 0. And our alpha is at 0.05. And so we're going to have a T0 for our test statistic. This time on our picture, we're going to be shading to the left because it's a left-tailed test. And then always we'll have our p-value, and we'll compare that to our alpha, and then we'll have a step 6. Now, notice that part E at the bottom says construct a 98% confidence interval for the population mean. So we'll do that as well momentarily, but first we're going to run the hypothesis test, but we'll be able to use the one sample mean for that as well. So let's go back to our Desmos program, and our sample size now is 6. Our sample mean was a negative 0.1667, and our sample standard deviation was 0.450. Oopsie. 502. Okay. And then our H0 stays the same. Our test statistic is a negative 0.907. And we are going to go down, and we're not doing a greater than this time. We are doing a less than test, and I'm going to click on the picture. And our p-value this time is a 0.202 negative, I'm sorry, 0.203 basically when we round appropriately. Make sure I typed everything in okay up here. 0. And we'll go back to our paper to make our decisions. And this time our p-value is greater than alpha, so we do not reject H0. Okay, and so there is not sufficient evidence to support the claim that the mean differences are less than 0. There's no point in further conclusion on this one. Now it says construct a 98% confidence interval. So our alpha is 1 minus 0.98. So alpha is 0.02. And alpha divided by 2 will then be half of that. Our formula is in the chapter 10 formulas, but it's really just going back to the single mean confidence interval formula. So we're going to be using this again with a T alpha divided by 2, and then our standard deviation of the differences and square root of n. So essentially we have negative 0.1667 plus or minus our critical T, right, is going to be degrees of freedom of 5 and alpha divided by 2, which is 0.01. So 0.01 and 5 is going to be 3.365. And then our standard deviation is 0.5402 divided by the square root of 6. And so we can put this into Desmos, and then we can also check with the program. So let's go ahead and do that. So I'm going to go up and use the program. We already put the data in here. But our thing we have to change is our alpha. Our alpha is 0.02, so it creates the confidence interval appropriately. And I'm going to click on the picture. So here's our confidence interval. There's a lot going on there, so it might be good just to go down and look at the lower bound and upper bound. So the lower bound is a negative 0.7852, and the upper bound is 0.4518. Okay, and let's just validate that if we were to use the numbers that we had in our Desmos. So if we did negative 0.1667 minus 3.365 parentheses our standard deviation divided by, we need the square root of 6. And we do indeed get the same lower boundary that we had from the program. And then if we just switch that to addition, we get the upper boundary. So that does match. So here is our confidence interval, our lower and our upper. And the question says, does this interval imply a significant difference in the two groups? So if there were a difference, if there were no difference, let's say, so if there were no difference, 0 would be in the interval, and 0 is within the interval. So there is no significant difference because 0 is within the interval. Okay, if 0 is in the interval, then you can't say that there's a difference between them. And that matches, even though we're doing a different confidence interval, 98%, and up here would have been a 95%, they did not reject either. So essentially, they're giving us the same report. Again, this is questions 17 from the final review. And the last problem from today, this video, is problem number 21, because again, it's similar topic, similar data, as far as similar data type. It says a statistics student heard that an individual's arm span is equal to the individual's height, but he believes that they are different. To test this hypothesis, the student collected a sample of students and measured their height and arm span. StatCrunch hypothesis test output is below. And so this is paired, even though it doesn't look like it up here, it's paired data because we paired a particular student from their height to their arm span. So this is paired data. So this is still 10.4. Okay. So that's why there's just the difference, and then they've averaged the sample differences average, and then their standard error and the degrees of freedom, the test statistic, and the p-value. So it says, is the sampling method dependent or independent? It's dependent. How many people were sampled? And the degrees of freedom is 9, so that means there were 10. What are the degrees of freedom? 9. What was the average difference? That's right here, a negative 0.4. What was the standard deviation for difference? Okay, they gave us the standard error. Standard error is equal to the standard deviation divided by the square root of n. So they gave us this, 0.781025 is equal to, we don't know the actual standard deviation from the sample, but it was the square root of 10. So if we multiply both sides by the square root of 10, we can find the standard deviation. So let's go to Desmos and do that. So if we say, the square root of 10 multiplied by, make sure you're multiplying outside of the square root there, multiplied by 0.781025. Then we can find out our sample standard deviation was 2.4698. So it says, which hypothesis is being tested? And they said that the student, but he believes that they are different. So it's just a not equal to, and you can see that here as well in the StatCrunch. So it's a not equal to. State the test statistic, it's negative 0.5121. State the p-value, 0.6209. That's right here. And if we flip the page, Organize and use the computer output to perform step 4. So we've got a picture and it's just shaded on both sides because it's a two-tailed test. So our p-value of 0.6209 is split between here and here. If the researcher set alpha at 0.05, would the results be statistically significant? So of course, we're going to compare our p-value to the alpha, and it's much bigger. So we do not reject H0. So results are not statistically significant. And then it says if the researcher set alpha at 0.05, what conclusion would be reached? So that would be our step 6 here. Okay. So there is not sufficient evidence to support the claim that a person's height and arm span are not equal. So for what we can see, they are equal. We cannot reject H0. And again, this is problem 21 from the final exam review. So that ends this video. Catch me back for some more review problems.